P because the M was already used for mass. So P is going to be the symbol for momentum. We know mass, the standard unit, is in kilograms. And we know velocity, standard unit, is a meter per second. So the standard unit for momentum is a kilogram meter per second. And so that's the standard unit of momentum. What this is really saying when you look at momentum, and I'll rewrite it here, P equals mass times velocity, is that both of these mass, if you increase the mass, the momentum increases. If you increase the volume, the momentum increases. So they're both directly proportional. You hear this quite often. Oh boy, especially in football, you hear, oh, the momentum carried the receiver out of bounds, or he played pull it all, the momentum carried the cue ball into the rack, or what have you there. So momentum, again, is always conserved. And we're going to do a couple quick problems here with momentum. You've got the worksheet on these, but we'll do a couple here also. Let's just say, for instance, we got a football player, and this football player is running on the field, and this football player has a mass of about 100 kilograms. And this football player is running down the field at about 20, let's say 2 meters per second. We want to know how much momentum this football player will have if he hits somebody, or if he's tackling, or he's blocking, or anything like that. So we know P equals, or momentum equals, mass times velocity. Well, we know the mass is 100 kilograms. And I like to put things in parentheses. We know his velocity, and again, velocity is a vector unit, so that's 2 meters per second is his velocity. So his momentum is 100 times 2, so it would be 200 kilogram meters per second. So there's a very simple problem with momentum on here. If you look at this, we can solve for a lot of different variables. This is very similar to force. We should be able to solve for all of these. So momentum equals mass times velocity. Well, given 2 out of 3, we can solve for mass. Mass equals momentum divided by velocity. And if we take this equation right here, we can solve it also for velocity. And so we can say velocity equals momentum divided by mass. So here again, we're using the old factor of cross multiply and divide. Cross multiplication is already done here in the basic formula, so we're just doing dividing. So we find momentum equals mass times velocity. If we want to solve for mass, we know it's momentum divided by velocity. And if we want velocity, we know it is momentum divided by mass. One thing to always remember here is momentum is always conserved. Momentum is conserved. What that is really saying is when you say a tackler tackle the quarterback, or a car accident, the momentum is always conserved between the two. It's probably beyond the scope of this class a little bit to get into that. When you take physics, you'll run into that a little bit more. But momentum is conserved, and that's assuming there's no other outside forces like friction in the air, like heat, or friction between anything in the ground. So this is the big one here we're really looking at. You've got a worksheet with some problems, and you should know how to do that. All right, this is a pretty short one, and that's the last one on momentum.